Hello, we're here with Andre today, and he's going to tell us about fusing online and face-to-face social networks with Python and wearable sensors.
Hello, I'm Andrea Panisson. I'm a researcher at ISI Foundation in Turin, Italy. And I would like to show you how we used Python to merge, to collect information from social tags, social sensors, and merge it with information that we collected from online networks. So imagine that you are in a conference like PyCon, and you meet a lot of different people, and you would like to keep in contact with them, but you have to exchange business cards and mails and so on. So imagine now that you can go anytime to a website and get information about the contacts, the people that you met, and not only their information, but also when you met them and how long was the conversation with them. So I'll show you how we did it. What is exactly a social sensor? The social sensor is this small sensor that is an RFID tag, and this tag is active RFID radio frequency identifier, and it is able to exchange information in a range of around 2 meters. So imagine that these two guys are having a conversation, so their tags are able to communicate with each other. And when they communicate with each other, they send information to the active RFID readers that are present in the conference rooms. The RFID readers, they are connected to a local network. And through the local network, they send information to an aggregator that's implemented using different Python libraries. So, for example, we use Twisted to listen for UDP connections, PyLibPcap to parse UDP packets, and our own version of XXT to check for CRC. So the aggregator is able to produce two types of Python objects. If the sensor is just reporting its presence on the conference, so we produce a sighting object. If the sensor is reporting a contact with other sensors, we produce a contact object. So all these objects are serialized and sent to the backend server, and the backend server is responsible for keeping information about the current status of the contact network using a graph representation. So now the other side. So each sensor can be associated to an online account. So when the participant receives the sensor, they can go to a website and can use the identifier to associate this identifier with all their online accounts. We can collect information from Facebook, Flickr, Last.fm, and Delicious, and we send everything to our RDF store. And well, we merge everything, and in the backend server, we use the RDF format to send everything to the clients where you can see it in real time. So we have different types of visualizations. In the first visualization, we focus on a user, and the user can see their online connections and also their social interactions. In the other visualization, we have the current status of the graph, the contact graph, and we put the users next to the readers that are receiving their information, and when two users are in contact with each other, we draw a link between them. So merging all this information, all this architecture is able to process thousands of users at the same time, and merging everything, we are able to enhance the social experience of the participants. So because the users are able to browse their information, and it's very cool. So our collaborators are ISI Foundation in Italy and the University of Southampton in England. And if you want to know more about our project, you can go to our website. It's www.socialpatterns.org. Thank you.
Thank you very much, Andre.